Simply Science, Magnetism. All types of magnets, like this bar magnet on the left and the horseshoe magnet on the right, have north and south poles. Running through the poles are lines of force called a magnetic field. The Earth is like a giant bar magnet. It has a magnetic north pole and south pole. The Earth has a magnetic field that runs through those magnetic poles. This magnetic field is what enables a compass to always point north. What happens if you take two magnets and put the south pole of one magnet next to the south pole of another magnet? Like poles, that means the south pole of one magnet and the south pole of another magnet, or the north pole of one magnet and the north pole of another magnet, repel or push each other away. What happens when you put the opposite poles together? This means you put the north pole of one magnet near the south pole of the other magnet. Opposite or unlike poles attract. That means they pull toward each other until they touch. Now that you know how the poles react to being near each other, what would happen if you hung a bar magnet on a string and then put a second bar magnet in your hand and placed the opposite poles of the two magnets near each other, north pole to south pole? If you said that the magnet hanging on the string would swing toward the magnet in your hand, you would be right. The north pole and the south pole would be attracted to each other. Now, what would happen to those same two magnets if you tried to put like poles together, north and north, or south and south? Like poles would repel each other. That means the magnet on the string would swing away from the magnet in your hand. Now, let's review what we have learned about magnets and magnetic fields. We learned that all magnets have a north pole and a south pole. The opposite poles, in other words, the north pole of one magnet and the south pole of another magnet, will be attracted to each other. They will pull toward each other. However, like poles, that means the south pole of one magnet and the south pole of another magnet, or the north pole of one magnet and the north pole of another magnet, will repel each other. They will push away from each other. We also learned that the Earth has a magnetic field, just like a bar magnet. This magnetic field allows a compass to always point north. I hope you have enjoyed learning about magnets and magnetic fields.